This video is a quick demonstration of modeling active transport using the sodium-potassium pump. Please follow along on your data sheet provided. To start out, we have our cell membrane with the sodium-potassium pump, and we have ATP on the inside, which is going to serve a purpose here in a moment. We also have 7 sodium molecules. Those are the blue circles. 1, 2, 3, 4, 5, 6, 7. And 8 potassium molecules. Those are the purple squares inside of the cell. 1, 2, 3, 4, 5, 6, 7, 8. I've written 7 next to intracellular Na+, that's intracellular sodium. I've written an 8 next to intracellular K+, that's intracellular potassium, or the amount of potassium inside of the cell. Outside of the cell, we have 8 sodiums, 1, 2, 3, 4, 5, 6, 7, 8, and 7 potassiums, 1, 2, 3, 4, 5, 6, 7. To start our sodium-potassium pump, we're going to do a very important step where we're going to fuel it using ATP. We're going to break one piece of our phosphate off of the ATP, and it's going to fit in this spot right here, kind of like the way a gas pump fits into a car. I like to use an analogy because ATP is the energy that's fueling the movement of this protein pump. The directions on the model say to use the protein pump to move 3 sodium molecules out of the cell. So we're going to fit 3 sodiums, 1, 2, 3. And because it has the ATP fueling it, the protein pump is going to push those sodiums out of the cell. In addition, the sodium-potassium pump is going to take 2 potassiums from outside the cell and go back to its original position to deposit those 2 potassiums into the cell. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sodiums outside of the cell, which I've written here, and only 4 sodiums inside of the cell, which I've written here. 4 sodiums inside, 11 sodiums outside. For potassium, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inside of the cell, so I've written 10 here. And we have 1, 2, 3, 4, 5 outside of the cell, which I've written right here. Now we're going to do this one more time just to show it. So first we're going to take 3 sodiums, 1, 2, 3. And the pump is going to change shape and push those sodiums out of the cell. And 2 potassiums, 1, 2, are going to move into the cell. Again, this movement is being fueled by the phosphate that came off of ATP. ATP provides energy for this movement. So now, on the inside of the cell, we only have 1 sodium, so I've written a number 1 right here. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 potassiums, which I've written right here. On the outside of the cell, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sodiums. So I've written a 14 here. But only 1, 2, 3 potassiums, which I've written a 3 right here. The important takeaways from this model are that we're moving more sodium out of the cell even when the concentration of sodium outside the cell is already high. We're moving against the concentration gradient. In the same way, we're moving more potassium into the cell, even though the potassium concentration is already high. Again, we're moving against the concentration gradient. The sodium-potassium pump requires energy because it's moving sodium and potassium against the concentration gradient.